Let's do number 7. Let's do this one. I guess some of you are already getting tired now. Let's do this one. Number 7. What is given? Let's go through the problem together. O is the center. O is the center. Thank you. BP is equals to OB. BP, we mark it on the diagram, mark it. BP is equals to OB is equals to OA. OA and OB, those are the radii, because O is the center. Therefore, they are also equals to BP. PTR is a tangent. PTR, this line is a tangent. Then you think of a tan-cot theorem. Then you think of the tan-cot theorem. EP perpendicular to AP. Here is this EP perpendicular to AP. Here is 90 degrees here. Thank you. Let's go to the first question. Prove that TEPB is a cyclic quad. TEPB is a cyclic quad. To simplify the problem for us, let's say we've got angle E1 here, angle E2, T1, T2, T3, B1, B2, B3. Thank you. We try and simplify the problem. Prove, the question states, prove that TEPB is a cyclic quad. TEPB is a cyclic quad. When? When will TEPB is a cyclic quad? There are 3 ways. I think those theorems must just be, they must come automatically to you. Once the question says prove that TEPB is a cyclic quad, then you think of the 3 possibilities. If the exterior angles equals the interior opposite angle, if the opposite angles are supplementary, if the angles at the same side are equal. Check this one. And you relate that to the given information. See, look at the given information. What is given? They are given that this angle is 90 degrees. And O is the center. So it means AB is a diameter. If AB is a diameter, 7.1. If AB is a diameter, it means angle T3. Angle T3 is equals to 90 degrees. Angle T3 is equals to 90 degrees. That is an angle subtended by diameter. Because it is given that O is the center, and we know the straight line that passes through the center is a diameter. So AB is a diameter. So T3 will be equal to 90 degrees. Angle P is also equal to 90 degrees. Why do we say angle P is equal to 90 degrees? Because it is given that EP is perpendicular to AP. This one is given. Given that EP is perpendicular to AP. That's why we say this angle P is equal to 90 degrees. Therefore, we draw a conclusion. It means angle T3 is equals to angle T3 is equals to angle P. What is the reason? They are both equals to 90 degrees. Both equals to 90 degrees. So if this angle is 90 here, let's mark it. It's 90. You look at P. What is the relationship? T3 and angle P. How do they relate? You can see that with respect to TEPB, T3 becomes an exterior angle. Angle P becomes the interior opposite angle. Therefore, we conclude by saying, remember the question, TEPB. TEPB. This is the conclusion. TEPB is a cyclic quad. Is a cyclic quad. Why do we say TEPB is a cyclic quad? Because the exterior angle is equals to the interior opposite angle. That's the first part. Now that we have proven that TEPB is a cyclic quad, it means we can apply the properties of a cyclic quad on that. Which other properties do exist? Like T2 is equals to E1, it's correct. Like B1 is equals to T1, that will be correct. Angles are the same chord. Those are the theorems that we can apply because we have already proven that TEPB is a cyclic quad. That was the first part of the question. Let's go to the second part. The second part of the question, 7.2. Prove that triangle ATB, let's go to triangle ATB, ATB, this triangle, ATB, this triangle, is grabbing the circle. Triangle ATB is similar to triangle, let's check, APE, APE, the bigger triangle. Triangle APE and triangle ATB. By merely, if you start, remember, to prove similarity, to prove that two triangles are similar, you only need to prove two pairs of angles to be equal. You only need to prove two pairs of angles to be equal, because the remaining pair definitely be equal. Remember, angles of a triangle add up to 180 degrees. Angles of a triangle, they are supplementary. They add up to 180 degrees. So if the first two pairs are equal, automatically the remaining pair will also be equal. So that's why I'm saying, if the question states, if you are required to prove the similarity between any two angles, just to prove the first two pair of angles to be equal, because the remaining pair will automatically be equal. Thank you. Let's look at triangle ATB and ATP. There's something common. Angle A belongs to the two triangles. Angle A belongs to the two triangles. We say angle A, we are answering 7.2 now. 7.2. Angle A is equals to angle A. It's common. Is common. ATB, AEP. So A is in both triangles. Angle T3 is equals to, this angle T3 is equals to P. We have proved that in number 1, both equals to 90. Or you can say proved in 7.1. Remember 7.1, we proved that T3 is equals to P. That's why we concluded that T3, that's why we concluded that TEPB is a cyclic quad. Or you can say T3 is equals to P, exterior angle of a cyclic quad is equals to the interior opposite angle, because we have proven that TEPB is a cyclic quad. So T3 is equals to P. So in triangle ATB, we have talked of angle A, we have talked angle T3, we are left with angle B3. We haven't yet talked about angle B3. And in triangle APE, in triangle APE, we have talked of angle A, we have talked of angle P, we still have to talk with the whole of angle E. Let me say angle E, it means it's both angle E1 and E2. Those will be the remaining angles. If you apply the theorem that says angles of a triangle are supplementary, therefore those are the remaining angles, therefore they have to be equal. Now, order is very much important here. It's very much important. Therefore, triangle ATB is similar to triangle, check, remember, angle A is common. We started with A here, must also start with angle A. AT, we went to T, remember T3 we said is equals to P, then you go to P. B3 is equals to that E, then you go to E. And you must always provide a reason. Triangle ATB is similar to triangle APE. The reason, provide a reason. Angle, angle, angle. Because we've talked of the first pair of angles here, the second pair of angles, and the third pair. So that should be the reason. I think 7.2, we've done it well. Let's look at 7.3. 7.3.